So here is my servo control. Let me verify that with the potentiometer it turns from 0 to 180, and there on the serial monitor we see printed on the left the analog input from 0 to 1023, in the middle the T control, and on the right the expected degree. And as we go up we get the full range. I increased it from 2300 as the TC max to 2400 because it wasn't quite getting to 180 every time, and this way it does. On the theory from lecture, each of the 8 codes is going to increment up. We're going from 0 to under 5, which is around 4.375. We can see this reflected in as we see the 100% or all on value for the DAC and circuit lab is 4.375. If I go in here and switch one off, we can see that it changes. Oops, that wasn't right. We can see that it changes, and that accounts, or that lines up with our calculations. Then here we get our actual DAC, which is quite convoluted, but I will show the output as it goes. So there we go. This is outputting the expected degree value, the control value, and the input from the digital read, or analog read rather. And when we change our states, we see that it goes up, and so these percentages of each of these can be taken as a percentage of 1023 for how close we're getting to that full voltage. And so the built DAC outputs correctly, and demonstrate that the servo has 8 positions with the DAC that we've created. So starting at 0, 0, 0, we go to the first position, which is 1, 0, 0, and it rattles around because it's a servo being powered by a false PWM. Go up to 0, 1, 0, which is a little bit further. Then we go up to 1, 1, 0, which is a little further yet. Then we go up to 0, 0, 0, 0, 1, which is halfway. Then we go to 1, 0, 1, which is a little bit farther. 0, 1, 1, which is a little bit farther, and then finally all the way to 1, 1, 1. The potentiometer being a fully analog input rather than a set of 8 analog inputs, has much more precision over the DAC controlling the servo. We wanted to increase how much we could control the position of the servo, meaning if we could decrease the degree increments, then we would need to add more bits, because there's only 3 bits, there's only 8 possible divisions of 180 degrees that are possible. So adding more bits would mean creating smaller increments.